Hello everyone, welcome back on our YouTube channel Physics Made Easy Kota. Today we are going to learn about the chapter Atom and Nuclei. This is the fourth part of the chapter. In this chapter we learn about the radioactivity and about the nucleus. So, for the nucleus, the size of the nucleus always matters. The first experimental determination of the size of the nucleus was made from the result of Rutherford scattering of alpha particle, and it is also observed that and concluded that the size of the nucleus vary linearly with the mass number, that they have the direct relation with the mass number. If the mass number is more, then the size of nucleus will be more. Next, what about the density? We all know density is always mass per unit volume. So for the nuclear density, mass per unit volume of a nucleus is called the nuclear density. Nuclear density is a constant and it is independent of the mass number of a nucleus. Nucleus consists of protons and the neutrons. Neutrons and the protons together known as the nucleons. But there is a difference between the mass of these nucleons which are present in the nucleus and the complete mass of the nucleus. This difference in the mass is known as the mass defect. Stability of a nucleus is also required. So to account for the stability of a nucleus, concept of a forces, that is the nuclear forces, arises. Nuclear forces are assumed to be the strong attractive force of magnitude greater than the Coulomb's repulsive forces. These forces are responsible for the stability of a nucleus. So there are the various properties of the nuclear forces. The first property is that nuclear forces are the strong fundamental forces in nature. That the magnitude of the nuclear forces between two protons is 100 times the Coulomb's electrostatic repulsive force and 10 raised to power 36 times the greater than the gravitational attractive force. So we can say that they are the more stronger than the Coulomb's repulsive force and they are able to keep the nucleons bound in a very small nucleus. Second property is that they are the non-central forces, which means that the force between the two nucleons does not act along the line joining their center. Next, these forces are short range forces, that these forces only exist inside the nucleus, and next that these forces are also known as the exchange forces because nuclear forces are due to the exchange of the pi meson between the nucleons. So they are known as the exchange forces. Nuclear force is also a saturator force. Nuclear force becomes quickly zero when distance between the two nucleons is just about 3 fm. Thus, a nucleon can attract only the nearest neighbor and it has no influence on the other nucleons. Radioactivity is one of the phenomena which deals with the spontaneous emission of radiations by heavy elements. There are the different types of the radioactive elements that show this phenomena. So why they show such kind of the behavior? So there is a respective cause between this phenomena, that the heavy nuclei are unstable and due to the instability that become the cause for the radioactivity. Binding energy per nucleon play a very great role, that the binding energy per nucleon for such nuclei, those having the mass number greater than 140, keeps on decreasing slowly. It means that the heavier nuclei are not stable, so that all the nuclei which have the mass number greater than 140 are led to be having the instability. So we can say that heavy nuclei have large number of the protons and the electrostatic repulsion between protons badly affect the nuclear forces. So it make the heavy nucleus unstable. So electrostatic repulsion have a great impact in making the instability of the heavy nuclei. But the physical conditions like temperature and pressure do not affect radioactivity. During the process of the radioactivity, some of the rays get deflected. Positively charged rays are the alpha rays, and the alpha particle is equivalent to the helium nucleus, that it contains the two protons and the two neutrons. Here are some properties: that they have the rest mass equal to 4 times the mass of the protons. They are deflected by magnetic field as well as by electric field. They can cause the skin burns. They are scattered by the thin metallic foils, and also they slightly affect the photographic plates. Negatively charged rays which are deflected are known as the beta rays, and the beta particles are the negatively charged particles, and their charge equal to the charge of the electrons. Their rest mass is equal to the mass of the electron. They are also deflected by electric field as well as by magnetic field. They affect the photographic plates. They cause the fluorescence in some substances. The rays which are not deflected are uncharged, and they are known as the gamma rays or high energy photons. There are some properties: that first of all, they have no charge and their relative rest mass is 0. They are not deflected by electric and magnetic field because they consist of no charge. They travel with the speed of the light in vacuum. They have all the properties of an electromagnetic wave. Law of radioactive decay, which is also known as a disintegration. So the rate of disintegration of a radioactive substance at any instant is directly proportional to the number of the nuclei in the radioactive substance at that time. There are the certain rules which are obeyed. So the rule number 1 is radioactive decay is a spontaneous process. It means that it is not affected by the whatever the external conditions may be, whatever be the temperature, pressure, it will not be affected. Next law state that at a time a nucleus will emit one alpha particle or one beta particle only. Both alpha and beta particles are not emitted simultaneously, and gamma rays emission follow the emission of alpha or beta particles. So when a radioactive element decays by emitting a beta particle, the position of the new formed element, which is known as the daughter element, is raised by one position in the periodic table. When a radioactive element decays by emitting a gamma rays, its position remains the same in the periodic table. Whenever it decays by emitting the alpha particle, then the position of the daughter element is down by 2 places in the periodic table. Nuclear reactions. The process by which a stable element is changed to another element, and its stability is destroyed when it is bombarded by an energetic particle. First nuclear reaction was performed by the scientist Rutherford. He bombarded nitrogen with alpha particle and obtained oxygen and proton. Nuclear reactions are of two types. The first one is a nuclear fission. It is a process of splitting a heavy nucleus into two lighter nuclei, releasing large amount of energy. For example, uranium is bombarded with a thermal neutron. Then it is found that the products are obtained along with the 3 neutrons and large amount of energy. Barium, krypton along with the 3 neutrons are formed. Second type is a nuclear fusion, in which the two lighter, very small nuclei combine to form a nucleus which has a large mass number. For example, when two nuclei of the deuterium fuse together, the new product is formed, that is the helium and the neutron. Similarly, for the another isotopic form of the hydrogen. Now here is some difference between the chemical reaction and the nuclear reaction. For the chemical reaction, one substance is converted into the another, but atoms never change their identity. For the nuclear reaction, atoms of one element typically converted into atoms of another element. Only electrons take part in the chemical reaction. Nucleus of elements take part in the nuclear reactions. Small amount of energy evolved during chemical reaction, but a large amount of the energy released during nuclear reaction. Reaction rates are influenced by temperature, concentration and catalyst for the chemical reactions, but for the nuclear reactions, reaction rates are depend on the concentration of the elements. It do not depend upon the physical conditions and the catalyst. So thank you for watching. Keep watching our channel. Take care. Have a nice day.